So the reason why today is so easy is because I have derived a formula for you. Normally, if you would have had to do this on your own, you would have to logic your way through it a little bit. You would have to know when to add and when to subtract from a certain point. Instead, we can just boom use this formula. So the formulas are listed down here. Now, when we're finding a fractional distance, so a point, say, a third of the way from one point to another, we are going to end up with a what? A single value, do you think? On a coordinate plane? What are you going to end up with? So it's a coordinate point. You have to find the x value and the y value. So you are actually going to be solving two equations here for each problem. One for x and one for y. Lucky enough for you, they are exactly the same, except one is for x and one is for y. So, solving for x starts with x at the start. I like to abbreviate that x with a sub s, plus the fraction, we'll just put a big F, times x at the end, x sub e, minus, again, x at the start, x sub s. So looking at this, what do you think our problem is going to tell you? So you're going to have a fraction, right? And you obviously have 2 points. Do you think it's going to matter which one we start with? It matters a lot. You need to make sure that every time you're looking for what your starting point is versus your ending point. That is going to be the biggest mistake on these problems. Knowing which one is the start and which one is the end. And it's the exact same for y. We have y at the start plus the fraction times y at the end minus y at the start. Yeah. All right, so let's do this example up here. I'm going to rewrite our equations. How many equations are we solving? Two, right? One for x, so x at the start plus the fraction times x at the end minus x at the start. That's our first equation. And our second equation is for what? Y. So y at the start plus the fraction times y at the end minus y at the start. Yes? S. So, on this problem, it says find the point a fourth of the distance from 3, -2 to -5, 4. What do you think we need to ask ourselves first? Which one's the start? So which of these points is our starting point? Yeah, it says from 3, -2 to -5, 4. That means we're starting at 3, -2. And we're ending at -5, 4. So that 3 is our what?
Starting.
X at the start. And the -2 is the? Ooh. Y at the start. The -5 is the? X at the end. Good. And the 4 is the? Y at the end. Wonderful. I'll make these different colors. X at the end. Nope, sorry. Y at the start. So, we're looking for our what first here? X at the start. So what is our x at the start? 3. What is our fraction? 1/4. So we're going to put 1/4 here. What is our x at the end? -5. And what is x at the start? 3. Yes.
What if it was a -3 where you just...
We'll see. That's going to happen here. You'll see. It's going to happen in the next one. All right. So what is -5 minus 3? And what is -8 times a fourth? -2. So what is 3 plus -2? 3 plus -2? 1. So x is 1. Yeah, it's not that hard. What? Sometimes you'll get decimals. Okay, y now. What is our y at the start?
-2.
-2. So where is it? Where is it? -2 is in blue. And what's our fraction?
1/4.
And what is y at the end? 4 minus y at the start. So, what do we see happens here? Yeah, what's 4 minus -2?
6.
So it's 4 plus 2, which is 6. What is 6 times a fourth? 3 over 2. So -2 plus 3/2. What do we get? You're right. -1/2. You could also, when we're in coordinate points, I will allow for decimals. Because really it is easier to plot a coordinate point when it's in decimals versus fractions. So, do you think I'm done? What do you think I need to write? I need to write the actual coordinate point here. What is my coordinate point? Beautiful. Any questions on fractional distance? Yes?
Would you allow mixed numbers?
I do not ever again in math want a mixed number. Improper fraction or decimal or proper fraction. No mixed numbers. Any other questions?